So the GroupedObj class is going to use a lot of the NGL library. In particular, it's going to inherit from the NGL abstract mesh class. Now the abstract mesh class is exactly what it says. It's all of the data you need to generate a mesh. So it contains information about face structures, vertices, normals, UVs. And it's designed basically to give me a consistent structure for generating meshes in the NGL library, creating vertex array objects and everything else. So internally what we have a class called face, which basically replicates the same face structure as the OBJ file. We indicate the number of vertices, and then we have a series of stud vectors that will allow us to store indices into our list of indices stored within the class. We then have another series of containers in here to store the actual data itself. So you can see here we have a stud vector of vertices, normals, textures, another one of faces. We do calculations for centers, bounding boxes, various other elements. And then we have a pointer to an internal vertex array object class, which again is the core NGL data structure for drawing anything within OpenGL. And we will use that to create a vertex array object of all of the data that we've stored within NGL. So if we have a look at the GroupedObj class itself, I've got a class diagram here. We are going to have all of the features of abstract mesh, and we're going to extend it to store the current mesh name, the current mesh material, the number of faces in there, and offsets. These are used internally when we're defining the actual class. Then we're going to have the ability to save and load in both text format and binary format. We're going to have the ability to draw, access to the current materials, and then we have a whole load of internal parsing structures here, which are primarily just for when we're reading in the OBJ file. The other element of data that we store in this is this structure, which I've called mesh data, and it's a standard C++ structure that gives us the ability to store in a internal stud vector the information for each of the individual groups that we will find in the class. So here we have the name of the mesh, the current material. The start index is the index to start drawing from within the vertex array object that we create. All of the data will be loaded in and create a single vertex array object. Then what we can do, we can only draw a portion of that by specifying, when we actually call the draw method in our vertex array object class, this version of it here, which start point in draw arrays we're going to use. So GL draw arrays takes in a mode. That would be GL triangles, GL points, whatever mode we want to use. A start index, which is an index into the data buffer of where to start, and then the number of vertices. So as I'm parsing the data, every time I find a new group, what I'm going to do is store that information and then use that later so I can draw individually the different elements. And I've also created an overloaded operator. I know this is in a structure, but as we're using C++, C++ will effectively treat this like a class. And I'm going to use this to sort my material at a later stage so that I don't have to change the materials each time. If I've got them sorted in a list, I can bunch together draws so that I'm efficiently using OpenGL.